Kia ora whanau. Welcome to part 2 of calculating probabilities using the standard normal distribution table. Please consult part 1 if you have not watched part 1 yet. So this is case 3 of the probabilities that we need to be concerned about. So again, the length of branches from a kahikatea tree plantation is assumed to be normally distributed with a mean of 1.8 meters and a standard deviation of 0.18 meters. Calculate the percentage of branches that are larger than 2.2 meters. I'll give you a moment, try and think about what that's going to look like. Now remember, we need to visualize. Visualization is the key here. So on the left I have the normal distribution with our mean of 1.8 meters as the central point and the standard deviation of 0.18. Remember, to calculate our probabilities or to find our probabilities using the table, I need to work with the standard normal distribution table. So the standard normal distribution is the diagram on the right with a mean of 0 and a standard deviation of 1. So there's my 2.2, and I've put a similar line on the standard normal distribution sketch there. And that's the area that I want, because the question is saying that we are concerned about the branches that are larger or bigger than 2.2 meters. So in terms of the area that we want, or the part of the standard normal distribution sketch, there we go in the orange. So the blue and the orange should be exactly the same size. That is, we will get the same probabilities. So now what we need to do is find that question mark, the value of that question mark. And remember, if you watch part 1, you will be well familiar with this. There's our formula there. X minus m over standard deviation. We are calculating z. There's our values there, so we're going to take 2.2 minus 1.8 in the numerator and divide that by the denominator of the standard deviation, 0.18. We get an answer of 2.222. So now let's go to our standard normal distribution table. Here we go. There's my picture there, and there's my table. So let's go straight into it. Let's look up 2.222. There's 2.2, 2, 2. Oh, sorry, 2.2. There's that. Let me back up a second. 2.22. All right, and that's the probability I'm concerned about. 0.4864. Now I've got to consider, because the number is 2.222, I've got to look at the differences column as well, and there's a additional 1 I need to add onto there. So in terms of the probability, it's 0.4865. Now there's a little trick to this, because if you remember from case number 1, that the number that we look up, 2.222, in our table actually gives us this part in the blue here. What we want is this part in the orange. So what we need to realize is that half of the picture, half of the sketch, adds to 0.5 or 50%. And so in order to get our final answer there, we need to take away the blue piece from the total of 0.5. So there's our probability, 0.0135, and finally there's our percentage, 1.35%. The final case will be case number 4. So that's correct, obviously. Let's press on. Okay, a length. So I won't read that out again because it's the exact same scenario. But this time, what we are looking for is the proportion of branches that are less than 1.45 meters. So less than meaning smaller than, obviously. 1.45 is obviously less than the mean, so that's why I've put it there. And I've shaded in the relevant pieces for us as well. So again, we need to find what that number is, the z value. Using our formula, x minus m, which is 1.45, take away 1.8, all divided by our standard deviation will give us our value of negative 1.944. Now it's the negative because, again, it's to the left of the mean and the standard normal distribution sketch. So the mean is 0, anything to the left is negative. But don't worry too much about that, because we're going to end up ignoring the negative anyway when we look up the number in our table. So there's our sketch. Let's look up the number now. 1.94. So there's our probability of concern, 0.4738. The differences column will give us the 2 that we need to add on. So 1.944 is what we have looked up in our table. In terms of the final probability there from the table, it's 0.4740. Now, keep in mind that when we look up 1.944 in our table, oh yes, we did ignore the negative, so that's fine, please take that into account. What we have found is the orange piece. We don't want the orange piece, we want the blue piece. Remember from case 3 that half of the diagram is 0.5. So what we're going to do, or 50%, so what we're going to do is take the orange piece away from the total. So 0.5, which is the orange plus the blue, take away the probability that we've found. That color coding is a bit off there, but I hope you'll follow that. And our final answer will be 0.026. Now, a final note I want to add there is that if you are asked to calculate, find, or investigate risk, probability, or proportion, they mean the same thing. If you are asked to find a percentage, you will be multiplying by 100 either the risk, the probability, or the proportion. Thanks for watching.